Hello students, today we'll discuss the assignment number 7 on relations and functions. Okay, so here you have your first question. You have to find the domain of your function. So solution is what? Solution is, sir, if you observe this thing, so fx is under root over something. Okay, so this function is defined whenever your quantity which is in under root sign, that must be greater than or equal to 0. So it means you can say 0.625 to the power 4 minus 3x minus 1.6 to the power x into x plus 8, that must be greater than or equal to 0. Okay, now if you observe 0.625 is what? 0.625 is 0.625 which is equal to 625 divided by 1000. Yes, so when you simplify it, you can say 125 is 625, and if you divide 1000 with 125, you'll get what? 8. So this thing is what? This thing is 5 by 8. Okay, now next thing is 1.6. So 1.6 is what? That is 16 by 10. So 16 by 10 is equal to what? That is 8 by 5. Okay, 8 by 5. So now you can say this thing is 5 by 8 to the power 4 minus 3x. Okay, and greater than equal to what? You can take this thing on the right hand side. So this will be 8 by 5 to the power x square plus 8x. Yes. So now we know exponential functions are always positive. Yes. So here we have one more thing, that is x power minus 1 means what? X power minus 1 means 1 by x. Whenever x is, obviously whenever x is non-zero. Okay. So you can say here x is what? X is non-zero, 5 by 8. So we have x power something minus of 4 plus 3x. Yes. And x is non-zero. So you can say this thing is 8 by 5 to the power 3x minus 4. Yes, greater than equal to 8 by 5 to the power x square plus 8x. Got it? Now, sir, 8 by 5 is what? 8 by 5 is greater than 1. Okay, so here base is greater than 1 and this value is greater than this value. So it means power 3x minus 4 must be greater than x square plus 8x. So from here you can conclude 3x minus 4 must be greater than or equal to x square plus 8x. So when you simplify it, you can say x square plus 8x. It implies what? X square plus 8x, and you can take 3x on the right hand side. So this is minus 3x, 4 on the right hand side, that is plus 4, that is less than equal to 0. So from here you can say x square plus 5x, x square plus 5x plus 4 less than equal to 0. Okay, so here you can say factorization is x plus 4 into x plus 1 less than equal to 0. Okay, this thing x plus 4 into x plus 1 less than equal to 0. So if you observe using wavy curve method, you can say that x belongs to minus 4 to minus 1 close interval. Yes, because you have equality also. So this is what? This is the values of x. X belongs to minus 4 to minus 1 closed interval. So this is what? This is the domain of your function. Okay, now let's do the next one. Next question is, find the domain and range of the function this. Okay, so sir, here we have fx is equal to log something to the base 2. Okay, so this function is defined whenever the input of your log is greater than 0. So it means pi plus 2 sine inverse 3 minus x by 7 divided by pi. Okay, divided by pi. Pi plus 2 sine inverse 3 minus x by 7 divided by pi must be greater than 0. Okay, now again I know till now we don't know so much about your inverse trigonometric functions, but again I am giving here you the solution of this question. Okay, you can revisit this question after your ITF, no problem in that. Okay, so pi plus 2 sine inverse 3 minus x by 7 divided by pi, which is greater than 0. Now we know about sine inverse, that is what? So sine inverse x. Sine inverse x is a function whose domain is what? Domain is minus 1 to 1, close interval, minus 1 to 1. And range is what? Range is what? Range is minus pi by 2 to pi by 2, close. Okay, so sir, if you observe here, sine inverse, first of all 3 minus x by 7, that must be what? Pi is defined here, 2 is defined, this pi is defined here, sine inverse 3 minus x by 7, that thing is defined whenever this 3 minus x by 7 lies between minus 1 to 1. So you can say, from here we can say 3 minus x by 7 must be in the interval minus 1 to 1. Okay, so it means what? It means multiply with 7 on both sides, you will get minus 7 less than equal to 3 minus x less than equal to 7. Subtract 3 from both the sides, you will get what? You will get minus 10 less than equal to minus x less than equal to 4. Okay, less than equal to 4. Now from here, if you multiply with minus sign, then inequality get reversed. So you can say x is what? X is from minus 4 to 10. Okay, minus 4 to 10. Got it? Now we know sine inverse x is what? That is a 1-1 function. Okay, so from here, if you observe one thing, so this thing cannot be minus pi. Yes, if this thing is minus pi, then the whole thing is 0, and 0 is not greater than 0. Okay, so now observe one thing. Sir, sine inverse lies between minus pi by 2 to pi by 2. So 2 sine inverse x belongs to minus pi to pi. Okay, and whenever your 2 sine inverse x is minus pi, so it means what? Sine inverse x is minus pi by 2. So if sine inverse x is minus pi by 2, so you have to find some theta for which your sine theta is minus pi by minus 1. Okay, sine inverse x is minus pi, so you have to find some theta, okay, such that for which sine theta gives you what? Sine theta gives you sine of minus pi gives you that value. Okay, sine inverse x means what? Sine inverse x. If sine inverse x is minus pi by 2, if sine inverse x is minus pi by 2, so it means x is what? X is sine of minus pi by 2, sine of that value. So that is what x means, minus 1. Yes, so sine inverse of minus 1 is what? Sine inverse of minus 1 is equal to minus pi by 2. Okay, you will discuss your inverse in your inverse trigonometric functions, that what is inverse sine x. Okay, arc sine x, sine inverse function. So it means that we can say this thing cannot be minus 1. So now, so sine inverse 3 minus x by 7 cannot be minus pi by 2. Okay, because if this is minus pi by 2, then that thing is minus pi, so this is 0. So it means 3 minus x by 7 cannot be minus 1. It means 3 minus x cannot be minus 7. Yes, so it means minus x cannot be minus 10. So it means x cannot be 10. So you have to remove your 10. So final answer is what? From these two you can conclude the domain of your function. From these two you can conclude the domain, and that is minus 4 to 10, 10 open and minus 4 close. Okay, so domain is what? Domain is minus 4 to 10, 10 is open here. Got it? So that's your domain. X belongs to this. X belongs to this. Okay. Next thing. Here you have to find the range also. Okay then. So let's calculate the range. So your function fx is equal to log of pi plus 2 sine inverse 3 minus x by 7 whole divided by pi to the base 2. Okay. Now, sir, we know sine inverse 3 minus x by 7 that lies from minus pi by 2 open to pi by 2 close. Yes, you cannot take minus pi by 2, otherwise this is 0. Okay. So now, if you multiply with 2, you will get what? Minus pi to 2 sine inverse 3 minus x by 7 less than equal to pi. If you add pi, you will get what? You will get 0 less than pi plus 2 sine inverse 3 minus x by 7 less than equal to 2 pi. If you divide by pi, you will get what? You will get 0 less than pi plus 2 sine inverse 3 minus x by 7 whole divided by pi less than equal to 2. Okay. Now, we know log x to the base a whenever a greater than 1 is an increasing function. So it means you can say if you take logarithm with the base 2, so log 0 means that is what? Log 0 to the base 2. That's not exactly 0, that's some greater than 0. So this thing is what? This thing is minus infinity less than. So this is log pi plus 2 sine inverse 3 minus x by 7 whole divided by pi to the base 2 less than equal to log 2 to the base 2, that is 1. Okay. And log pi plus 2 sine inverse 3 minus x by 7 divided by pi to the base 2 is what? That is your fx. Okay, this thing is what? This thing is your fx. So from here you can say fx minus infinity. From here you can say minus infinity less than fx, and fx is less than equal to 1. So you can say range is what? Range is all the possible values of your fx. So range is equal to minus infinity open to 1 close. That's your answer. Okay, minus infinity to 1 close. So this is your final answer for the range. Okay, so now you have domain and range of your particular function. Now let's do the next one. Third question, that is let x belongs to here, then find the domain of your function. Okay, so solution is what? So for this particular function, domain is what? Domain is, sir, minus log 10x to the base sin x. 10x to the base sin x. That must be what? That must be greater than 0. You cannot take equal to 0 because this thing is in the denominator. So from here you can conclude that log 10x to the base sin x less than 0. Multiply both sides with the negative sign, so inequality get reversed. Yes. Now we know that x belongs to 0 to pi by 2. So this thing is what? This thing is always less than 1. Yes. And greater than 0. Whenever x belongs to 0 to pi by 2, so sin x is always greater than 0 and less than 1. So your base is less than 1. So it means log 10x to the base something which is lies between 0 to 1 gives you negative value. So it means 10x must be greater than 1. We know that log x to the base a is negative whenever x and a both are on opposite side of 1. Okay, if this lies between 0 to 1, so 10x must be greater than 1. Okay, so tan x, from here you can conclude that tan x is what? Tan x must be greater than 1. You cannot include 1 here. Whereas tan x is equal to 1 also. Why? Because otherwise this is 0 and 0 is not less than 0. So tan x greater than 1. So if you observe the things, x belongs to 0 to pi by 2, so you can say tan x is greater than 1, tan x is greater than 1 whenever x belongs to pi by 4 to pi by 2, open interval. Okay, so this is the value of your x, that x belongs to pi by 4 open to pi by 2 open. This is the domain of your function. Okay, now let's do the next one. So find the domain and range of this function. Okay, you have to find domain and range. Okay then. Now, so sine is defined for every value. You know this thing, yes? And now log can take any value, minus infinity to infinity, yes? But log is defined whenever its input is greater than 0. So it means what? It means this 4 minus x square under root divided by, okay, under root 4 minus x square divided by 1 minus x, that must be greater than 0. So if this thing is greater than 0, so now one thing, so this is always what? This is always non-negative, yes? So it means if this thing is positive, so this must be greater than 0. So first condition, 1 minus x must be greater than 0. So from here you can conclude x is less than 1. Okay, first thing, x is less than 1. Okay, no problem. Now sir, you have one more condition, that is what? That is sir, this must be defined. So 4 minus x square must be greater than 0. You cannot take equal to 0, otherwise 0 is greater than 0 is not possible. So this thing is what? X square minus 4 less than 0, multiply with negative sign. So from here you can say x belongs to, minus 2 to 2, open interval. Yes, minus 2 to 2, open interval. Okay, this is your second condition, that minus 2 to 2, open interval. Now, what is the domain? Domain is the intersection of these two. So if you take intersection of these two, you will get what? X belongs to, this says minus 2 to 2, this says less than 1. So x belongs to minus 2 to 1. That's your domain. Okay. Next thing, you have to find the range also. You have to find the range here. That range is what now? Range. Okay. Sir, under root 4 minus x square upon 1 minus x. Okay. So, if you observe this thing, whenever x approaches minus 2, whenever x approaches very close to minus 2, so this thing is 0, yes? So you can say when x approaches to minus 2, I am saying when x approaches, I am not saying x is equal to 2. When x is very close to minus 2, then this thing is what? Numerator is 0. So you can say, let's say this one is what? This tends to 0, yes? So you can say under root 4 minus x square, upon 1 minus x. Okay, under root 4 minus x square divided by 1 minus x, that thing tends to 0. If this thing tends to 0, so it means what? It means, sir, it means log under root 4 minus x square divided by 1 minus x to the base e, that thing tends to minus infinity. Okay, if this thing tends to 0, so log 4 minus x square under root to the base 1 minus divided by 1 minus x to the base e tends to minus infinity. Now next thing, whenever x is very close to 1, when x is very close to 1, so your denominator tends to 0. Yes, and this is smaller than 1, so that is on the positive infinity. So you can say, sir, 4 minus x square under root divided by 1 minus x, this thing tends to infinity, positive infinity. And if this thing tends to positive infinity, so you can say log 4 minus x square under root divided by 1 minus x to the base e, this tends to infinity. Okay, and we know log is a continuous function, so it takes each and every value from minus infinity to infinity. Okay, so if it takes minus infinity to infinity all the values, so it means input for sine is what? That is real number. So if input for sine is real number, so you can say range is what? Range is minus 1 to 1. So you can say range is equal to minus 1 to 1 close interval. So this is your final answer. Okay, minus 1 to 1 close interval is the range. Okay, so this is the domain and range for your function. Now let's do the next one. Solution is, your question, write the function fractional sin x in piecewise definition. Okay, so fractional sin x is what? Fx is equal to fractional sin x, that is sin x minus greatest integer of sin x. Sin x minus fractional part is function minus its greatest integer. So sin x minus greatest integer of sin x. Now, so for the sin x, if you observe, you have some situations. Let's say these are your first and second quadrants here when you draw your x-axis and y-axis. So we know sin x is whenever your sin x lies here and here, I'm taking open circles here. Why? I'm not including that sin x is 0. I'm not including sin x is 1. Okay. For this, we'll discuss your fractional sin x in different case, you can say. Okay. So if you observe here to here, and then here to here. Okay. Here to here, excluding this one. So sir, here my function sin x lies between 0 to 1, open. Here my function lies between 0 to 1. Okay, then no problem. Now again, here to here and here to here. So here my function lies between minus 1 to 0. And here also minus 1 to 0. And on the open circles, here that is 1, here it is minus 1, here it is 0, here it is 0. Okay. So sir, we can say fx is equal to, listen carefully, fx is equal to what? Fx is equal to, sir, if this point is what? This is 0, this is pi by 2, this is pi, this is 3 pi by 2, then 2 pi, then 5 pi by 2. So these are what? These are the multiples of pi by 2. So you can say whenever x is what? Multiples of pi by 2, where n is what? N is any integer. N is 0, that's pi by 2, sorry 0, n is equal to 1, that's pi by 2, 2 pi, 3 pi by 2, 4 pi by 2, that's 2 pi. Okay, so whenever x is multiple of n pi by 2, sin x is an integer. Value of sin x is an integer, 0 and 1. So if sin x is an integer, so fractional of sin x is 0. Because we know fractional of integer is what? That is 0. Okay, now next thing. Whenever you have 0 to 1 here or here, so sin x lies between 0 to 1. So it means its greatest integer is 0. So you can say function is sin x. Function is sin x. When? Whenever x is what? X belongs to? X belongs to what? X belongs to, sir, this point is 2n pi. This is 2n pi plus pi by 2. This is 2n pi plus pi. And this is 2n pi minus pi by 2. So you can say 2n pi, x belongs to 2n pi open to 2n plus 1 pi open. Yes, whenever x belongs to 2n pi open to 2n plus 1 pi open, then this is sin x. But you have to remove one thing from here, from this interval. That is what? This point. Yes, you have to remove odd multiples of pi by 2. So you can say this thing can be written as 2n pi to 2n pi plus pi by 2 open union 2n pi plus pi by 2 open to 2n plus 1 pi where n belongs to z. Okay, n belongs to z. Next thing, sir, whenever x is here, so sin x is from -1 to 0. Sin x is -1 to 0. So it means that is what? That is the value -1. So if this greatest integer is -1, so this is +1. So you can say sin x plus 1. Yes, sin x plus 1. Got it? So now you can say x belongs to where to where? Sir, x belongs to 2n plus 1 pi. Yes, from here 2n plus 1 pi to 2n plus 2 pi. Yes, you can say this thing is what? 2n pi and then 2n pi plus 2 pi also. So this is sin x plus 1 whenever x belongs to 2n plus 1 pi to 2n plus 2 pi. Here we have to, means we have to remove this one or not? No need to remove this one. Why? Because at this greatest integer of sin x is again -1, because the value of sin x is -1. Okay, that's automatically 0. Okay, you will get the same thing. Okay, so this is x belongs to 2n plus 1 pi to 2n plus 2 pi where n belongs to what? N belongs to an integer. Okay, got it? So that this is what? This is your piecewise definition of the given function, fractional part of sin x. Got it? Now let's do the next one. So next is find the domain of this function, denotes this, and this denotes the fractional part function. Okay. So sir, domain is what? Domain is sin x fractional part of sin x plus fractional part of sin pi plus x. Okay, this domain for this function is what? Your denominator must be non-zero and the quantity which is in under root, that must be greater than 0. Okay, so it means that must be greater than 0. Yes, so fractional sin x plus fractional sin pi plus x must be greater than 0. So if you observe this thing, so from here we can say this is fractional sin x plus this is fractional sin pi plus theta is minus sin theta, so fractional minus sin x. Fractional sin x plus fractional minus sin x. Now we know this has two values. Either this is 0 or 1. So this thing is 0 whenever your sin x is an integer. When sin x is integer. And this thing is 1 when sin x is not an integer. When sin x does not belongs to an integer value. So it means your domain is what? All real values where your sin x is an integer. Yes? Domain is all the real values except where sin x is an integer. And we already know from the last question that sin x is integer at n pi by 2. So it means your domain is what? Domain is, sir, x can take any real value except collection of all n pi by 2 such that n belongs to an integer. Okay, that's what? That's the domain. So x belongs to R minus n pi by 2 where n belongs to integer. This is my domain. Okay, why? Because at n pi by 2 your sin x is an integer and you have to remove these values. Okay, so this is the final answer for your domain. Now, next question. Solution is, sir, fx is equal to this one, then prove that fx is equal to minus time of f minus x, where this denotes greatest integer and this second function denotes the fractional part function. Okay then. So if you write f of minus x, so let's discuss this one. F of minus x means what? Now replace x with minus x. So this is greatest integer of minus x. Whenever, sir, this lies between 0 to fractional of minus x is less than 0.5. Okay, and this thing is greatest integer of minus x plus 1 whenever this lies between 0.5. This means your fractional of minus x. Fractional of minus x lies between 0.5 to 1. Okay. So if you replace x with minus x, so you will get this thing, no problem, easy. Now your input is minus x, so replace x with the minus x. Now, you can say this is what? This is, so you can take 0 here, yes? Whenever your fractional of minus x is 0. Whenever fractional of minus x is 0, then this is what this is? Greatest integer of minus x. Okay, no problem, greatest integer minus x. Okay. Whenever 0 to 0.5, 0 to 0.5, 0 to 0.5. So this thing is what? Greatest integer of minus x. No problem. Yes, next one is 0.5 to 1. 0.5 to 1. This thing is greatest integer of minus x plus 1. Now you know two properties. One is what? One is this one. Sir, greatest integer of okay, so leave it. Observe here. Minus x is what? Minus greatest integer of minus x. Now you can say this thing is what? This thing is, one thing is sure here, that your x is not an integer. Why? If x is an integer for these two parts, if x is an integer, then their fractional is 0. Yes, got it. So, but we have fractional between 0 to 0.5, some non-zero quantity. Similarly in the next one. So you can say, if x is not an integer, so greatest integer function satisfy one property, that is what? greatest integer x plus greatest integer of minus x is minus 1. So you can say this thing can be written as, second one, minus 1 minus greatest integer of x, because greatest integer of x plus greatest integer of minus x gives you minus 1. So greatest integer of minus x is minus 1 minus greatest integer x. Whenever 0 to, now fractional of minus x, we have one more property here. Okay, these are the properties. Fractional x plus fractional of minus x gives you 1. So fractional of minus x is what? That is 1 minus fractional x. Yes, and here got it? And in this minus fractional minus greatest integer x is minus 1 minus greatest integer of x plus 1. Okay, and now this thing is what? Fractional of minus x is 0. Fractional of minus x is 0. So it means fractional x is what? Fractional x is also 0. Yes or no? Fractional x is also 0. Because if this thing is 0, so it means x is an integer. And if x is an integer, so this is 0. Next. Now this one is what? Greatest integer of minus x. That is minus of greatest integer x. If x is an integer, now we know that x is an integer here. Yes, this is minus greatest integer x. Now observe this thing. Minus greatest integer x whenever fractional x is 0. Okay. If you simplify this thing, 1 minus fractional x lies between here to here. So fractional x is from where to where? Okay, so let's simplify this one. 1 minus fractional x between here. Okay, so you can say 1 minus fractional x. 1 minus fractional x from 0 to 0.5. So it means you can say minus 1 to minus 1 is less than minus fractional x and less than minus 0.5. Multiply with negative sign, so you can say 0.5 to fractional x less than 1. Okay, using simple inequalities, facts of simple inequalities. Yes, so this thing is what? Fractional x 0.5 to 1. So it means what? Fractional x is from 0.5 to 1. Fractional x is from 0.5 to 1, or let's say here 0.5 to fractional x 1. Yes, fractional x lies between 0.5 to 1, and this thing is what? Minus 1 minus greatest integer x. So you can take minus common, so this is greatest integer x plus 1. Okay, next thing, you can cancel minus 1 with 1, so this thing is minus of greatest integer x, and when you simplify this thing, subtract 1 on both sides, you'll get minus 0.5 to 0. Okay, if you multiply with the minus sign, so you'll get 0 to 0.5. Okay, so fractional x is where? This is 0 to 0.5, 0 to 0.5. Okay, that is from 0 to 0.5. Now you can observe f of minus x is what? Okay, now you can combine first of all these two things. Yes, when you combine these two things, you will get what? You will get this one. F of x is equal to f of minus x. Sorry. Yes, f of minus x. F of minus x is equal to, sir, minus greatest integer x. Minus greatest integer x. Whenever x is from 0 to 0.5. 0 to including fractional x to 0.5. Yes, and minus time greatest integer x plus 1 whenever 0.5 to fractional x lies between 0.5 to 1. Okay, so if you observe here, this is, if you multiply with minus sign, so that is minus fx is equal to minus of greatest integer x whenever this fractional x belongs to 0 to 0.5 minus fractional x minus 1.5 to 1. Okay, when you multiply with minus, so you get the same result. Yes, so you can say this is equal to minus of fx, and from here you can say fx is minus time f of minus x. Fx is equal to minus time f of minus x. Yes, that's the proof that fx is equal to minus time f of minus x. Okay, that's the proof, hence proved. Okay, so this is your question number 7. Now next question is here. Solution. Function f is from minus 3 to 4. Good. To real number, fx is equal to 2x, and g is from minus 2 to 6 to real number, gx is equal to x square. You have to find f plus gx. Okay. So first of all, f plus g is defined from this f plus g function is defined in common domain. So common domain is what? My first one, f is defined from minus 3 to 4. So if you draw your number 9, so let's say this is minus 3, this is 4. Okay, so fx is defined here minus 3 to 4. G is defined from minus 2 to 6. Minus 2 is somewhere here and 6 is somewhere here. So this is defined from minus 2 to 6. Okay, close. So what is the common portion? So common portion is minus 2 to 4. Okay, so this is defined from minus 2 to 4 close to real number. Okay. Now you have to find f plus gx. So f plus gx is what? F plus g of x. We know this is defined as fx plus gx. And you already know fx is equal to what? Fx is equal to 2x. And gx is equal to what? Gx is equal to x square. So you can say, you can take x common and this thing is x plus 2. This is your f plus g of x. Okay, that's the answer. Got it? So here you have to find f plus gx. This is your f plus g of x. Now next thing, question number 9. Solution is, so here your functions are non-uniformly defined functions. Here's piecewise definition. They have piecewise definition. So first of all, you have to make their domain same. Here if you observe that function is less than, domain means you have to define in the same intervals. Yes, x less than 1, here you have x less than equal to 2. So you cannot add, they have different definition. Here 1 to 2, this one has 2x minus 1, and here 1 to 2, this has 3x. Okay, so you have to make first of all the same piecewise function in the same domain, same intervals. Yes, solutions are what? Solution is fx is equal to less than or equal to 2, and this is less than 2. Okay, so it's less than 1. So you can say your function is x cube wherever x is less than 1. So write gx also side by side. Gx is equal to what? Gx is equal to, sir, 3x. Whenever x less than equal to 2. So whenever x less than equal to 2, so you can say x is also less than 1. Okay, the same definition. Gx takes same definition whenever x is less than 1, because 3x whenever x is less than equal to 2. So 3x whenever x is less than 1. And from 1 to 2, 1 to 2, again your function take 3x. Yes, and here less than 1 x cube, and greater than or equal to 1 this has 2x minus 1. So 1 to 2 also have the same definition. 1 to 2. that is 2x minus 1. Okay, and whenever x greater than 2, definition is 2x minus 1. And here what is the definition? Whenever x is greater than 2, so x greater than 2, definition is x square. Okay, so now you can add your functions. Yes, you have both the functions now defined in the same intervals. Yes, so basically they have their piecewise definitions for the same intervals here. So you can say f plus gx is what? F plus g of x. So find f plus gx. So f plus g of x is, you already know, that is fx plus gx. So you can add your functions whenever x is less than 1. So whenever x is less than 1, so fx is x cube and gx is 3x. So you can say this is x cube plus 3x. Okay, x cube plus 3x whenever x is less than 1. Next one, 1 to 2, this is 2x minus 1, this is 3x. So when you add them, you will get 5x minus 1. 5x minus 1 whenever 1 to 2 you have. Next is 2x minus 1 plus x square. So you can say this is x square plus 2x minus 1 whenever x is greater than 2. Okay, so this is what, this is the answer, f plus g of x. Got it? Now next question is, solution. Similar kind of question, yes, fx and gx, and here you have to find f by g and its domain. So sir, fx is what? Fx. And here define your gx. So that is less than 4, that is less than 3. So you can say this thing is x square minus 4x plus 3 whenever x is less than 3. Okay. So if x is less than 4 and definition is x minus 3, so same definition satisfied by x less than 3? Yes, so you can say this is x minus 3 whenever x is less than 3. Okay. Got it? Now, sir, 3 to 4 open. 3 to 4 open. So whenever x is greater than or equal to 3, okay, greater than or equal to 3 but less than 4. So definition is what? Definition is x minus 4. Okay, here. So 3 close to 4 open. Definition is what? Definition is x minus 3. X greater than or equal to 4. Definition is x square plus 2x plus 2. Okay. Here whenever x is greater than or equal to 4, definition is x greater than or equal to 4, definition is x minus 4. Got it? Now the definitions are, now we have definitions of fx and gx in the same intervals. So now you can find f by g. So f by g of x is fx by gx, and this thing is what? So fx by gx. So this is x square minus 4x plus 3 divided by x square minus 4x plus 3 divided by x minus 3. No problem. When x is less than 3. Okay. But now 3 to 4. 3 to 4. 3 close to 4 open. That is x minus 4 divided by x minus 3. X minus 4 divided by x minus 3. But you cannot take x is equal to 3 here. Why? Because denominator is 0. So you have to remove 3 and you have to say that x lies between 3 open to 4 open. Okay, you have to remove 3 from here. Next, whenever x is greater than or equal to 4, x greater than or equal to 4, definition is what? Definition is x minus 4, f is this one, fx upon gx. Gx is what? X square plus 2x plus 2. X square plus 2x plus 2. And you can observe x square plus x plus 2 is what? that is always positive quantity. How? Because this thing can be written as x plus 1 whole square plus 1. X square plus 2x plus 1 and plus 1 is 2, and this is what, this is always greater than 0, positive. So no need to remove any point from here. Okay, so clearly this is your f by g function, and if you have to find the domain, so you can say your function f by g takes defined for each and every value except 3. Yes, less than 3 you have, greater than 3 you have, yes, at 4 you have the definition, or greater than 4 you have the definition. But x is equal to 3, your function is not defined, so domain is what? Domain is sir, all real numbers except 3. Yes, except 3. So that's your domain, r minus 3. Got it? So that's the answer, final answer for your question. Okay? Now let's do the next one. Now you have MCQs, single correct, yes, single correct multiple choice questions. So just a minute. Now for this you have to find the domain of your function, and function is 2x plus 2 power y, 2 power x plus 2 power y is equal to 2. Okay, now let's discuss the solution. So you have 2x plus 2 power y is equal to 2. So from here you can say 2 power y is equal to 2 minus 2 power x. From here if you take logarithm, so you can say log 2 to the power y to the base 2 is equal to log 2 minus 2 power x to the base 2. Okay, 2 power x to the base 2 minus 2 power x to the base 2. Okay, that thing is what? That thing is y. Okay, we already know the properties of logarithm, so this thing is what? This thing is y, and y is equal to log 2 minus 2 power x to the base 2. Okay, so sir, this thing is defined whenever 2 minus 2 power x is greater than 0. So from here you can say 2 power x less than 2. Okay, 2 power x less than 2, and you know that 2 power x is always greater than 0, so you can say this is 0 to 2. Now you can take logarithm on both sides, so if you take logarithm, so you will get minus infinity x and 1. Okay, so you can say x belongs to minus infinity to 1 open. So that is your final answer. Okay, minus infinity to 1 open, or minus infinity to 1, that is D. Okay, so D is the correct one. Now next thing, here we have, so find the domain of the function here. Okay, and solution is, this thing is defined whenever log of 1 by mod sin x greater than or equal to 0. Okay, okay sir, no problem. So sir, this thing is defined whenever log 1 by mod sin x greater than or equal to 0. Yes, because under root quantity is defined whenever this is greater than or equal to 0. So log 1 upon mod sin x. Yes, wait. Yeah, log 1 upon mod sin x, yes, whatever be the base, I think that is e, that must be greater than or equal to 0. Okay, next thing, from here you can say 1 by mod sin x. 1 by mod sin x must be greater than equal to 1. Yes, first condition, that 1 by mod sin x greater than equal to e power 0, that is 1. And second condition is what log is defined whenever 1 by mod sin x greater than 0. Yes, 1 upon mod sin x greater than 0. Okay, so now observe one thing. We know mod sin x is always lies between, mod sin x cannot be 0, first thing, otherwise your definition 1 by mod sin x, that is not defined here. So first thing is what, mod sin x cannot be 0. Yes, you cannot take mod sin x as 0. Okay, so it means mod sin x, if you observe the range, so mod of sin x now belongs to 0 open to 1 close. So if mod sin x is here, so obviously 1 by mod sin x is where? Always greater than or equal to 1. Okay, and yes, mod sin x is lies between 0 to 1, so 1 upon some positive quantity is always positive. So it means you can take every value of x, every real value, except where sin x is 0. Mod sin x is 0 means sin x is 0, and sin x is 0 at n pi. So this is n pi where n belongs to integer. So you can take every real value except where sin x is 0, and that is sin x is 0 at n pi. So x belongs to r minus n pi, n belongs to z. So B is your final answer. Okay. Now next question is, find the domain. For the domain, so first thing is x square minus 1 must be greater than 0. So from here, x minus 1, x plus 1 must be greater than 0. So if you apply the wavy curve, you will get what? You will get minus infinity to minus 1 union 1 to infinity. Yes? When you draw your wavy, means when you apply your wavy curve, you will get what? You will get minus infinity to minus 1, positive, union 1 to infinity. Okay. Now, log of input is now, okay, input is greater than 0. Next thing, your base 3 plus x. 3 plus x, that must be greater than 0. It means x is greater than minus 3. And x plus 3 or 3 plus x, both are same thing, cannot be 1. So it means x cannot be minus 2. X cannot take the value minus 2, otherwise your base will be what? 3 minus 2 is 1. That's not possible. So if you take the intersection, now you have to take what? Intersection. Yes, you have to satisfy both the inequalities, both the things simultaneously, this and this. So you can say, if you take intersection, so x belongs to, that is minus 3 to infinity except minus 2, and this is minus infinity to minus 1. So you can say minus 3 open to minus 2 open, union minus 2 to minus 1, minus 3 to minus 2, union minus 2 to minus 1, union 1 to infinity. Okay, that's the answer. So minus 3 to minus 2, union minus 2 to minus 1, union 1 to infinity. So this is what, this is your C option. So C is the correct one. Okay, so answer for 13 is C. Okay, next thing. That's the question. So solution is, here sir, you have to find the range of your function 1 upon sine fractional x, and then greatest integer of 1 upon sine fractional x. Yes, so sir, Now solution is what? Sir, observe one thing. Fractional x, you have to find the range. So fractional x is what? Sir, fractional x always belongs to 0 to 1. Yes. Now, so sign of fractional x, that belongs to sine 0, that is 0 to sine 1. Because 0 to 1 your function is increasing, sine is increasing. Yes. You can observe this thing from your graph also. So 0 to 1, sine 1. So it means what? It means, so sine fractional x cannot be 0 because otherwise that thing is not defined. Okay. So, but we can say sine fractional x cannot be 0. So from here you can say now we can say, so sine of fractional x always belongs to 0 to sine 1. Okay. Now, if we know sine fractional x, so we can find 1 upon sine fractional x. That belongs to, from the facts of your inequalities, yes, law of reciprocal. If you know x, so you can find 1 by x. If both are of same sign, means x belongs to a to b, and both are of same sign, then 1 by x belongs to 1 by b to 1 by a. Okay, so sine fractional x from 0 to sine 1, so 1 by sine fractional x belongs to, that thing belongs to 1 upon sine 1 to infinity. Okay, 1 by 0, that's infinity. Got it. Now let's check sine 1. 1 upon sine 1. What's the behavior? So if you observe about 1 by sine 1. So now, sir, we know 1 is less than pi by 3. Pi by 3 is what? Pi is 3.14 approx. So divide by 3, so that's greater than 1. So now sine is increasing. So from here you can say sine 1 is what? Less than sine pi by 3, which is root 3 by 2. From here you can say 1 by sine 1 is greater than 2 by root 3. Okay. That's approximately 1.5 something. Yes. 1.1 approximate. Yes, 1.15 something. You can calculate 2 upon 1.73. Yes, root 3 is 1.73. So when you divide, you will get 1.15 approx value. So that thing is 1.15, greater than 1.15. Now, but 1 upon sine 1 is what? 1 upon sine 1 is smaller than 2. Yes. 1 upon sine 1 is what? Smaller than 2. Yes, sir. Because sine 1 is what? Sine 1 is also always, if you observe here, that is pi by 4 is greater than 1. Yes. Then pi by 4 is root 2, 1 by root 2, sine pi by 4, 1 by root 2. Okay. So from there you can say that this thing is greater than 1 but smaller than 2. Yes, greater than 1 but smaller than 2. Yes, sir. Next thing. Or how can you conclude? Maybe you can do like this. Sir, now 1 is greater than pi by 6. Pi by 6, pi is 3.14, and when you divide by 6, you will get what? You will get smaller than 1, yes? So if you take sine, so sine 1 is what? Sine 1 is greater than sine pi by 6, that is 0, and then 1 by 2, 1 by 2. Okay? So from here, you can say 2 greater than 1 by sine 1. 1 by sine. So sir, now observe. 1 by sine fractional x belongs to some value which lies between 1 to 2 to infinity. So it means when you find the greatest integer of it, so greatest integer of 1 upon sine of fractional x, that belongs to what? That belongs to, sir, 1 sine 1 upon sine fractional x, 1 upon sine fractional x. Yes, 1 upon sine fractional x lies between 1 to 2, some number, first of all 1 to 2, that number is, let's say, 1 point something, I don't know, to infinity. So it means whenever your range from 1 to 2, you will get 1, when 2 to 3, then you will get 2, 3 to 4, you will get 3, 4 to 5, then you will get 5. So it means fx is equal to greatest integer of 1 by sine fractional x, greatest integer of 1 by sine fractional x, 1 by sine fractional x belongs to 1, 2, 3, 4, 5 and so on. Okay, so that's the range. So your question is, you have to find the range of your function where these are the greatest integer and fractional part functions. So this is what this is, sir, 1, 2, 3, 4, 5. So this is natural number, set of natural numbers. B, or yes, you have here 1, 2, 3, 4. D is also the set of natural numbers. So that's also the answer. Okay, you can take B and D here. Okay, any one of the option, any one of them. Okay. Out of these two. Okay, if you put B, then you will get the correct answer. D, then also correct. Okay, now let's do the next one. X and fractional x, these are the greatest integer x and fractional part x, then find the value of this one. Okay, sir. So solution is here. We have one property that fractional x plus some n gives you fractional x when n is what? N is any integer. You have this property, fractional x plus n gives you fractional x whenever n is what? N is an integer. Now you have to find this summation, find the value of this summation. So this is what? This is summation r is equal to 1 to 2000, 1 to 2000 fractional x plus r divided by 2000. Yes, so this thing is what? This thing is, sir, fractional x plus 1 divided by 2000 plus fractional x plus 2 divided by 2000 plus fractional x plus 3 divided by 2000 plus last is what? Last is fractional x plus 2000 divided by 2000. Yes, fractional x plus 2000 divided by 2000. So now you can take 1 by 2000 common. Okay, and you have fractional x plus 1. So this is fractional x. Fractional x plus 2, that's fractional x. Fractional x plus 3, that's also fractional x according to the property. And last one is also fractional x. So how many times you are adding your fractional x? 2000 times. So this is what? This is 1 by 2000 into 2000 times fractional x. So now you can cancel it and your answer is what? Your answer is fractional x. So final answer is fractional x. So C is the correct answer. Okay. Now let's do the next one. Okay then. Solution is here. For non-negative integers m and n, a function is defined as follows. Okay, got it. Then find the value of f11. So f11. F11 is what? F11 is both are non-zero. M and n both are non-zero. So this is your definition. So this thing is f of 0, put m is equal to 1, so this is 0, comma, f of 0, comma, not 0, that's 1, sorry, m is 1, yes, m is 1, f of 1, comma, n minus 1, n is 1, so this is 0. Okay, now, find f10 now, yes, so now f10 is what? f10, okay, let's do your work here. f10 means m is 1, n is 0. Okay, m is 1, n is 0. Got it. So m is 1, n is 0. So non-zero and 0. Okay, so put here in the second one. So you will get what? F m minus 1. If you put m as 1, so this is 1 minus 1, 0, comma. N is what? Your n is 0. So that is 1 minus 1, 0 and 0, comma 1. So this is 0, comma 1. Okay. This is what? This is 0, comma 1. And here you have this thing is f m is equal to 0. This is what? M is equal to 0. Now you have to find f of 0, 1. F of 0, 1 is what? F of 0, 1. F of 0, 1 means you are putting m is equal to 0. M is equal to 0 and here n is 1. So n is 1. So this value is 2. Okay, this value is 2. Got it? So f10 is f01 and which is equal to 2. So it means this thing is what? This thing is f of 0, comma f10 is 2. Now m is 0. If m is 0, so definition is this one. And value of n is 2. So this thing is n plus 1. That is 2 plus 1, 3. So final answer is 3. Okay. So final answer is 3. That's the answer. C. Okay. Next is solution. You have to find number of points on the real number 9 where the function is not defined. Where the function is not defined. It means if function is not defined, so x mod of x minus 3, that must be greater than 0. And we know mod is always non-negative. So mod of x minus 3 cannot be 0. Yes. This thing cannot be 0. Why? Because logarithm is defined, log x to the base a. Okay, if you write here log x to the base a, that is defined whenever x is greater than 0, a greater than 0 and a is not equal to 1. So from here you can say in your solution you can say, sir, mod x minus 3 must be greater than 0. Okay. So mod we know always non-negative quantity. It means your mod x minus 3 is 0 whenever your mod x minus 3 is 0. So you can say x minus 3 is 0 and from here you can say x is equal to 3. Okay, x is equal to 3. You cannot take x is equal to 3. Okay. We are finding the points which is not in your domain. So you cannot take x is equal to 3. If x is equal to 3, then this is 0 and log is not defined then. Next thing is you cannot take x square minus 1, mod of x square minus 1 is equal to 1 because base is not equal to 1. So from here you can say x square minus 1 is equal to either 1 or x square minus 1 is equal to minus 1. So from here or this is our situation. Yes. Next, if x square is equal to 1, x square minus 1 is equal to 1, so x square is equal to 2. So values of x are root 2 and minus root 2. Or x square minus 1 is equal to minus 1. So then this is x square is equal to 0. So if x square is equal to 0, so x is equal to 0. You cannot take x is equal to 0, root 2 minus root 2 and 3 till now. Okay. You have one more condition, that base must be greater than 0. So it means we have modulus here. So that thing is always greater than equal to 0. But you cannot take equality. So you have to remove all the points where modulus, mod x square minus 1 is 0. So it means what? It means x square minus 1 is equal to 0. It means x is equal to 1 or minus 1. So you have to remove these points also. Okay? So you have to remove 3, 0, root 2 minus root 2, 1 and minus 1. So total how many points are not in your domain? 2, 3, 4, 5 and 6. So 6 points are not in your domain. Okay? Next thing. So answer is here, not in the domain, that is number of points which are not in the domain, that is 6. So next question is, sir, solution is number of integral integers, number of integers in your domain. You have to find number of integers where this is greatest integer and this is fractional part function. So the first thing is, sir, write your function here. First of all, write your function. Fx is equal to what? Fx is equal to, so log 4 minus mod x. Log of 4 minus mod x to the base greatest integer of x square. Okay? Fx is equal to log 4 minus mod x to the base greatest integer of x square plus log fractional part of root x, fractional part of root x to the base 2. Okay? You have to find number of integers in your domain. So first thing is what? 4 minus mod x. First thing is what? First thing is that 4 minus mod x. This quantity must be greater than 0. If this is greater than 0, so you can say mod x less than 4. If mod x less than 4, you can say x lies between minus 4 to 4 open intervals. Okay, minus 4 to 4 open intervals. So how many integers now you have? Before that, so one more thing, you cannot take x as non-positive value, yes? You cannot take x less than or equal to 0. If x is less than 0, you cannot define your root, and if x is 0, then you cannot define your logarithm. So from here you can say x must be greater than 0. Okay, x must be greater than 0. We have other conditions also, that is not an integer, yes? Root of x cannot be an integer. So x must be greater than 0. So using these two, we can say how many integers we have now in our domain. So either 1, 2, 3 or 4. Yes? You have only 4 options now for your integers. Yes? X must be, your integer must be greater than 0, less than 4. Less than 4. Less than 4, yes. Less than 4. So you cannot take 4 here. So you have only 3 options till now. But now you cannot take 1 also. Why? Because if you take 1 here, that is root of 1 is 1. And fractional part of this is 0. Okay, and you cannot define your logarithm. So you have to reject your 1. Yes, now you can take 2, no problem. You can take 3, no problem. So how many integers in your domain? Sir, we have 2 integers and they are 2 and 3. So final answer for this is C, that is 2. Okay, 2 integers in our domain, that is 2 and 3. Got it? Okay then. Now the next question is, solution. Find the domain of function this represent the greatest integer function. Okay. Okay. So first thing is, okay, this represents the greatest integer. Okay. The signum 9 minus x square must be positive. Okay, because this is the input for your log, and input for log always greater than 0. So signum 9 minus x square must be positive. Okay, that must be positive, greater than 0. And signum gives you three values, -1, 0 and 1. So it means this thing must be 1. And signum takes 1 whenever your input is greater than 0. So it means 9 minus x square must be greater than 0. If this thing is greater than 0, so you can say x square minus 9 less than 0. And now from your wavy curve method you can say x belongs to -3 to 3 ohm. Okay, no problem. Next thing. Now, under root greatest integer of x cube minus 4 greatest integer x must be greater than or equal to 0. Yes, the quantity which is in under root sign, that must be greater than or equal to 0. So it means you can say greatest integer of x cube minus 4 greatest integer of x greater than or equal to 0. Okay, if this thing is greater than or equal to 0, so from here you can say greatest integer of x minus 2. Yes, greatest integer x you can take common, then this is x square minus 4, greatest integer of x square minus 4. So that is greatest integer x minus 2 and greatest integer x plus 2. This must be greater than or equal to 0. Okay, now if you solve using your wavy curve, so sir, that is 0, minus 2, 0 and 2. Okay, so next thing is plus minus plus minus. So greatest integer x belongs to -2 to 0, -2 to 0, union 2 to infinity, union 2 to infinity. Okay, that's the greatest integer x. So if greatest integer x is here, so what about x? What about x? What about x? What about x? From here you can say x belongs to -2. You cannot take value of x less than -2, otherwise your greatest integer is -3. So you can take -2 to 1. -2 to 1 open, but -2 you can take -2 close. Okay, union. That is too close to infinity. So it means what? It means, so you can take 2 to infinity. Yes, 2 to infinity. Got it? Now, so you have to satisfy both the inequalities simultaneously. So you have to take the intersection of these two. Intersection. So if you take the intersection, so intersection is -2 to 1, -2 to 1 close at -2, union 2 close to 3 ohm. That's the final answer. Okay, and so you have -2 close to 1 open, union 2 close to 3 open. So final answer is A. Okay, so this is your final answer. Now next question is here. And you have solution now. Now we'll discuss the solution. You have to find the range of this function. Okay, so if you observe fx is equal to what? Fx is equal to under root over 1 minus cos x. under root over 1 minus cos x under root over till infinity. So let's say this thing is y. Okay, y. And this one is what? This one is, this is 1 minus cos x to the power half. Now we have 1 minus cos x to the power 1 by 4. Yes, so you have 1 minus cos x to the power half plus 1 by 4 plus 1 by 8 plus so on till infinity. And this one is what? 1 by 2 and plus 1 by 4 plus 1 by 8 and so on. This is your GP. Yes. First term is half, common ratio is 1 by 2, yes, 1 by 2, then 1 by 4 by 1 by 2 is 1 by 2, then again 1 by 2 and so on. So sum is what? Sum is A upon 1 minus, first term upon 1 minus common ratio, that is 1 by 2. So this is 1 by 2 upon 1 by 2 which is equal to 1. So you can say y is equal to what? Y is equal to 1 minus cos x. 1 minus cos x. Now, so we know cos x is from cos x. Cos x belongs to minus 1 to 1. So what about minus cos x? Minus cos x also belongs to minus 1 to 1. Yes. And if you add 1, then 1 minus cos x belongs to, if you add 1, so you will get 0 to 2. 0 to 2 close. Okay, and 1 minus cos x is what? That's y. So you can say y belongs to 0 to 2 close. Okay, and this is what? This is your range. So 0 to 2 close, that's 2 open, no. So D is your final answer. Okay, D is the final one. So this is your final answer. Okay, now next thing. So sir, solution is here. This is what? This is again some MCQs and this is from your revision section. Okay. So now, first question is AB is equal to 1, product of AB is 1, then find the minimum value of these two things, this sum. So we know both the, if you take 1 by A power 4, obviously if AB is equal to 1, both are non-zero. If one of them is 0, then product is 0. Okay, both are non-zero. And if A and B are non-zero, then these two numbers, 1 by A power 4 and 1 by 4 B power 4, these two numbers are what? These two numbers are positive. Okay, so for the positive numbers you can say we have one thing, that is AM, arithmetic mean, greater than equal to geometric mean. Okay, so here if you take two numbers, 1 by A power 4 and 1 by 4 into B power 4, so you can say 1 by A power 4 plus 1 by 4B power 4 divided by 2, that's arithmetic mean, which is greater than equal to geometric mean, that is 1 by A power 4 into 1 by 4B power 4 to the power 1 by 2. Okay, so from here you can say this thing is 1 by A power 4 plus 1 by 4B power 4 greater than equal to 2 times, if you multiply with 2, so inequality remains same, yes. So this is 2 times, and if AB is equal to 1, AB is equal to 1, so if you take power 4, then you will get A power 4 into B power 4 is equal to 1 power 4, which is 1. So you can say this is A power 4 into B power 4 is 1. So this is 1 by 4 power half. Okay, 1 by 4 power half. And 1 by 4 power half is 1 by 2. So from here you can say this thing is 1 by A power 4 plus 1 by 4B power 4 greater than equal to 1. Yes, 1 by 4 power 1 by 2 is what? That's 1 by 2. 2 into 1 by 2 is 1. Okay. Now 1 by a power 4 plus 1 by 4 b power 4 is greater than equal to 1. So with something is greater than equal to 1, so minimum value is what? 1. So final answer is A here. Okay. Next thing. 22nd question is, solution is, sir, PQ are positive real numbers, okay, and we are given with this, and we have one more condition, that you have to find the value of this thing. Okay, so sir, PQ are positive, so you can say P plus Q plus R divided by 3, that's AM, greater than equal to GM, that is PQR to the power 1 by 3. Okay, this is AM greater than equal to GM. So from here you can say you are applying what? You are applying AM greater than equal to GM. Okay, so from here if you take cube on both sides, so you will get what? P plus Q plus R whole cube divided by 27 greater than equal to PQR. Okay, and from here you can say P plus Q plus R whole cube greater than equal to 27 times P, Q and R. PQ into R means PQR. Okay, and you have one more condition, that is P plus Q plus R cube given that is what? That is P plus Q plus R whole cube. P plus Q plus R whole cube less than equal to 27 PQR. Okay, so here you have P plus Q plus R whole cube greater than equal to 27 PQR, and here you have P plus Q plus R whole cube less than equal to 27 PQR. So from these two, okay, we know if A greater than equal to B and A less than equal to B, so we have only one possibility, that A and B both are equal. Okay, so situation is what? If you have A greater than equal to B, A greater than equal to B and A less than equal to B, so from here what can you conclude? Sir, we can conclude that A and B both are equal. If A greater than equal to B and A less than equal to B, then A must be equal to B. Okay, so it means from here you can conclude P plus Q plus R whole cube is equal to 27 PQR. It means AM is equal to GM. Okay, P plus Q plus R whole cube is equal to 27 PQR. So it means AM is equal to GM, and this is possible when all the numbers are equal. So it means you can say P is equal to Q is equal to R. So you have one more condition, 3P plus 4Q plus 5R. 3Q plus 4P, sorry, 3P plus 4Q plus 5R is equal to 12 plus 5R is equal to 12. But we know all the P, Q, R are same, so this is 3P plus 4P plus 5P is equal to 12. So when you simplify, you will get P is equal to what? 1. So if P is equal to 1, so now P is equal to Q is equal to R is equal to 1. Okay. If all the values are 1, now calculate 8P plus 4Q. 8P plus 4Q minus 7R. Minus 7R. Okay. If you calculate it, you will get what? You will get 8P plus 4Q minus 7R. So this is 8 plus 4 minus 7. PQR, all the numbers are 1. So 8 plus 4 minus 7. So this is 12 minus 7, which is 5. So 5 is the final answer. So D is the correct one. Okay. Now next one. So again, next solution is, let x, y, z are real positive real numbers. 2xy plus 3yz plus 4xz is equal to 18 if alpha, beta and gamma are the values of x, y and z for which x, y, z attain its maximum value, then the value of 2 alpha plus beta plus gamma is what? Okay. So now you have one thing here, that is, sir, x, y, z all are positive real numbers, so their products are, if you take the product of x and y and z, y and z all are positive. So you can say these numbers 2xy, 3yz and 4xz, these are positive numbers. So you can apply am greater than equal to gm again. Yes, am greater than equal to gm. If you apply am greater than equal to gm, so you can say 2xy plus 3yz plus 4xz divided by 3 greater than equal to 2xy into 3yz into 4xz to the power 1 by 3. So when you simplify it, you know this thing is what, 18. So this thing is 18 by 3, that's 6. Okay. So now you can take cube on both sides. So you can say this is 216 greater than equal to 24 x square, y square and multiplication with z square. Yes. So if you cancel with 24, means divide both sides by 24, so you will get what? You will get 9. Yes. So you can say x square, y square, z square, x square, y square into z square less than equal to 9. So from here you can say x, y, z is less than equal to 3. Okay. Clearly x square, y square, z square is a positive number, and if you have a square less than equal to b square, it means a less than equal to b. So x, y, z is less than 3. So if x, y, z is less than 3, less than or equal to 3, and we have what? We have said for which x, y, z attain its maximum value. So this attain its maximum value whenever all the numbers are equal. Yes, 2xy, 3yz and 4xz. Yes or no? These numbers are equal. Okay, so now we can say alpha, beta, gamma are the values of x, y, z for which x, y, z attain its maximum. So this attain its maximum whenever these numbers are equal. Yes, because this is what? This is about your am equal to gm, and this is true whenever your numbers are equal. So now you can say 2xy equals to 3yz equals to 4xz is equal to what? Is equal to, if these three numbers are same, so you can say, let's say this is some t, 3t is equal to 18, so t is equal to 6. This thing is 6. Okay. So from here you can say xy is equal to what? Xy is equal to 3, xy is equal to 3, yz is equal to 2, yz is equal to 2, and sir xz is equal to 6 by 4. Xz is equal to 6 by 4 means 3 by 2. That's 3 by 2. Okay. So sir, now xy is equal to 3, yz is equal to 2. So now what can we do? Sir, that's okay. 2xy is equal to this. Yeah. From here we can do. Sir, if you divide these two things, so you'll get 3 by 2. Yes, x by z. If you divide these two, you'll get what? Xy upon yz. That is x by z is equal to 3 by 2. Yes. Now we know x by z is 3 by 2. Xz is 3 by 2. So it means x by z, x is equal to 3 by 2z. Yes, you can put x is equal to 3 by 2z here. X is equal to 3 by 2 into z. So put here. If x is equal to 3 by 2z, so you can say So you can say 3 by 2z into z is equal to 3 by 2. So z square is equal to what? From here you can conclude z square is equal to 1. So value of z are 1 or minus 1, but you have to reject minus 1. Why? Because z is positive number. So z is equal to what? Z is equal to 1. If z is equal to 1, put the value here, xz is equal to 3 by 2. Okay, so x is equal to 3 by 2 and y is equal to what? Y is equal to, yz is equal to 2, z is 1, so y is equal to 2. Okay, so these are the values of x, y and z for which that attains its maximum value. So alpha, we are given by alpha, beta, gamma with the values of x, y, z for which x, y, z attain its maximum value. So it means alpha is what? Alpha is 3 by 2. So you can say now alpha is equal to 3 by 2, beta is 2 and gamma is 1. Yes, alpha is 3 by 2, beta is 2 and gamma is 1. Now you have to find 2 alpha plus beta plus gamma. So 2 alpha plus beta plus gamma is equal to 2 alpha is equal to 3 plus beta 2 plus gamma 1, that is 3 to 5 plus 1 6. So that's the answer. 6 is the answer, means B1. Okay, that's your final answer. Now next is 24th. So solution is here. Sir, we have to find the minimum value of this expression where x, y, z are positive real numbers. So sir, we can say x power 4 plus y power 4 divided by 2 is greater than equal to x power 4 into y power 4 to the power 1 by 2. We are applying am is greater than equal to gm. So when you simplify, you can say x power 4 plus y power 4 greater than equal to 2 times x square y square. Okay, 2 times x square y square. Now 2x square y square greater than 0. Okay, so you can say now 2x square y square plus, if you take next one is z square, okay, divided by 2, that is greater than equal to, yes, that is greater than equal to 2 into x square y square into z square. Okay, 2 times x square y square into z square to the power 1 by 2. Okay, yeah, got it. So from here you can say 2x square y square plus z square greater than equal to 2, and this is root 2 xyz, root 2 xyz. Okay, so now from here, from this step, from here you can say what? You can say if you add x power 4 plus y power 4 plus z square, so that thing is greater than equal to 2x square y square plus z square, and we know 2x square y square plus z square greater than equal to 2 root 2 xyz. Okay, and xyz are what? Xyz are positive real numbers, so you can divide by xyz, product of xyz. So you can say x power 4 plus y power 4 plus z square divided by xyz, yes, greater than equal to 2 root 2. You can take these two inequalities, yes, 2 root 2. Okay, so you can observe one thing, that x power 4 plus y power 4 plus z square greater than equal to 2 root 2 xyz. Now divide by xyz, you will get x power 4 plus y power 4 plus z square upon xyz. greater than equal to 2 root 2. Yes, and you have to find what? You have to find the minimum value of this thing, x power 4 plus y power 4 plus z power 2 divided by x, y, z, and if this thing is greater than equal to 2 root 2, so minimum value is 2 root 2. So final answer is B. Okay, that's the correct one. Now last question is here. So solution is here. If n1, n2, n3 and 100 are positive real numbers, you have 100 positive real numbers, and n1 plus n2 plus n3 plus till n100 is equal to 20. Sum of these positive numbers, 100 positive number is 20, and k is given to us, which is this thing. Okay. Now, sir, so in the solution we can say, if you observe, if you take numbers n1, then another number n2 plus n3 plus n4, another number is n5 plus n6 plus till n9. So you will get what? So first of all, till n100, how many pairs, how many you can say these collections we have, how many elements we have? Okay. So sir, n1 we have one element, n2 plus n3 plus 4 we have 3 elements, plus next one, so we have 5, 6, 7, 8 and 9, we have 5 elements. So next is 10, 11, 12, 13, 14, 15 and 16, we have 7 elements. So how many you can say elements we have in this particular thing in K? So sir, we have something, let's say this is some K, not K, we already have, let's say this is some M. Yes, we have M terms, and we have how many numbers, n1, n2 till 100. Okay, so this is what this is 100 numbers. Okay, so it means this is what this is 1, 3, 5, 7. We know this is 4, this is 9, this is 16. So till means if you have M, so you can say this is M number of terms, M number of terms. Okay, M number of terms you have. Okay, M number of terms. So you can say M square is equal to 10. M square is equal to 100. So M is equal to what? M is equal to 10. Okay, so you have 10 such elements, n1, then n2 plus n3 plus n4, second, third is n5 plus n6 plus n7 till n9, then till n10 to n16, then n17 to and so on, and 25 I think, and so on. Okay, so you have 10 pairs of 10 not pairs, 10 elements like this in your K. So now you can apply what? You can apply the AM greater than equal to GM. So how? So if you observe, this is your first element, so n1 plus, second is what? n2 plus n3 plus n4 plus n5 plus n6 till n9 and so on till n100. Okay, n1, n2, n3, n4, then n5, 6, 7 and 9, then so on till n100, divided by so how many elements you have? These are 10. Yes, these are 10 divided by 10. AM greater than equal to GM. GM is what? N1 into this, into next and into next. So that is what? That is K. Okay, so this thing is K, and K to the power 1 by 10. Okay, and if you observe this quantity, this is sum of n1 plus n2 plus n3 plus n4 n5 and so on till n100, that is 20. So you can say K power, from there you can say K power 1 by 10 less than equal to 20 by 10, that is 2. So from here you can say k less than equal to 2 power 10, and 2 power 10 is 1024. Okay, k less than equal to 1024, and k is what? Sir, n1, n2, n3 all are positive, so this must be greater than 0. Yes, so k must be greater than 0, and k must be greater than 0. So you can say k belongs to 0 open to 1024 close. That's the final answer. Yes, this is the possible values of your k. So you have to find what? You have to find then k belongs to in which interval? So k belongs to 0 open to 1024 close. Okay, 0 open to 1024 close. So D is your final answer. Okay, so this is what? This is your assignment number 7. So in next we'll discuss your assignment number 8. Okay, till then bye bye and thank you everyone.